Tracing mathematical eras, how to avoid historical bias. Have you ever thought about how numbers have traveled through time and across cultures? The story of mathematics is not just a tale of numbers. It is a rich narrative woven from the contributions of many civilizations. To truly appreciate this journey, we must be careful not to let historical bias cloud our understanding. First, it is essential to recognize that mathematics is a global story. From the earliest counting methods known as old tally systems for thousand years before the Common Era, to the sophisticated ideas developed in ancient Mesopotamia, Egypt, and India, every culture has played a role. Each era brought new styles of notation and concepts that reflected the unique influences of its time. For instance, the Bronze River era, spanning from 4,000 years before the Common Era to 1,001 years before the Common Era, marked significant advancements in mathematical thought. The Early Philosophic era, from 1,000 years before the Common Era to 301 years before the Common Era, saw the rise of formal mathematics, particularly in regions like Mesopotamia and Egypt. As we move into the Euclidean era, from 300 years before the Common Era to 599 years of the Common Era, we see the Greek contributions, especially in geometry. However, it is vital to remember that similar developments were happening simultaneously in China, India, and the Islamic world. The medieval Zero era, from 600 years of the Common Era to 1499 years of the Common Era, brought the concept of zero and the decimal place value system into focus, largely through the work of Indian and Islamic mathematicians. During the Renaissance and Gutenberg eras, from 1500 years of the Common Era to 1799 years of the Common Era, Europe experienced a revival of mathematical ideas. Yet, these ideas were built upon the knowledge preserved and expanded by earlier cultures. To avoid historical bias, we should recognize that mathematical knowledge was shared across cultures through trade, conquest, and scholarship. For example, the preservation of Greek mathematics by Islamic scholars played a crucial role in its later reintroduction into Europe. It is also important to understand that mathematical eras often overlap and influence one another. Different notations and methods, like the Chinese rod calculus or Indian trigonometric tables, developed independently but contributed to a shared understanding of mathematics. Avoiding Eurocentric narratives is key. We must acknowledge the contributions of Babylonian, Egyptian, Indian, Chinese, Islamic, and other mathematicians. Each played a part in shaping the world of numbers we know today. Lastly, considering the broader cultural and historical contexts that shaped mathematical ideas is essential. Astronomy, commerce, and philosophy all influenced how societies approached mathematics. By adopting this inclusive mindset, we can appreciate how mathematical concepts evolved as responses to real-world challenges faced by various societies. This approach enriches our understanding of numbers and their meanings, revealing that the fascinating world of mathematics is a shared human achievement that spans millennia and continents.